Thank you very much for the invitation to come. It's really a pleasure, and maybe I should add to your kind presentation here that also after listening to the previous presentations, I think that the community and the cooperative aspect of all this is extremely important, and this goes right to the heart of myself. I can add on a personal note that I live in a small community, a small village south of Aalborg in the northern parts of Denmark. I come from Aalborg University, and in this small community we have a cooperative of district heating owned by the heat consumers. We also have a biogas that produce biogas and used to produce for the district heating company that was initiated by the local farmers. And I also been the secretary of our local cooperative owning a wind turbine for many years until it was too old and we took it down again with 40 families. So I really like the cooperative and the community approach, and I think it's extremely important. But that's not what I'm going to speak so much about today. That's more the technical and economic aspects of converting the whole of Europe, Denmark and many countries, and the whole of Europe into 100% renewable energy. But I will add a little about the community while we're going along on these slides here, because I think that's really, really important if we are going to implement such ideas as this. What I will say something about is based, and we call it Smart Energy Europe, and I'll come back to why we call it that, but it's a proposal on how to transform the whole of Europe into 100% renewable energy. It's a report we made for the Commission, a very small report, and it's documented both in a paper and also in a report, so you can download it and read all the details if you wish, because I cannot possibly say all the details today. It will be more the overall lines of it. But I will also add something from the Danish context, because you can say making this paper study on how we can do 100% renewable energy in Europe is sort of based on a lot of studies we have conducted in Denmark and also in other countries, where we have promoted the concept of smart energy systems, and also made a lot of studies on how you can go from where we are now with fossil fuels and nuclear and so on, and into a 100% renewable energy solution. And this is also based on two books have been written or one book, it's two editions. It's called Renewable Energy System that look into a lot of the things that I'll speak about today. That's half of the book is all about how to convert this, how to design renewable energy systems from an economic and technical point of view. But listen to the previous speakers, and being here today, I would like to also to say that the other half of the book is about how you as a community and as a local citizen actually involve yourself in those fights that will be between shouldn't we have another coal-fired power station or another nuclear, or how could we fight that? So that's the other half, and that's based on 10 big energy decisions in Denmark and also in other countries that I have been involved in, and promoting renewable energy strategies, and how this fight then evolves, and how you take out the choices, and then you can, and so on and so forth. That's another story. I'll just mention it here. But if you go back to the more economic and technical part of it, what we promote is a special way of being smart, because today everybody wants to be smart, and I will not argue against being smart. That would be stupid to do that. but I will argue for a specific way of being smart, you can say. Some years ago, a little more than 10 years ago, was introduced this concept of smart grid, and I expect everybody in this room has heard about smart grid. And I think smart grid is good. Of course, we should be smart grid. But when you look into it, and that's why we have developed something else, when you look into smart grid, there is a problem, I believe, and that is all smart grid is defined within the sector of electricity. When you really go to the definition of it, you only look at the electricity sector. And that is a problem. And that's why we have tried to introduce, together with others, the concept of smart energy systems or smart energy. And the whole idea of this is to open up your mind and don't try to look for the solutions within the limits of one subsector, but to include all of it. And if you do that, in our opinion, that's what we argue, and I will try to convince you here today, then we can find much better and much cheaper and much more political liable solutions to how to make a 100% renewable energy. The problem, if you only look within the electricity subsector, is that you will see the world as we have some wind power that go up and down, and we have some electricity demand, and then we have a mismatch, and what should we do about it? And there are basically three things that you can do about it. The one thing is to make flexible demands, or you can do an electricity storage, or you can build some transmission lines to your neighboring countries and hope they can solve it for you. And those three solutions, in our view, cannot really solve the problem. And if you try to solve it by those three measures, it will become extremely expensive. And you cannot solve it. What you have to do is to include the heating sector and the transport sector and the biomass and the industry and everything, because it does not really make a lot of sense to be renewable in the electricity sector and not in the other sectors anyway. So, but if you do that, then we will have better and cheaper solutions, and we can do it much easily. And that's what we try to promote in what we call the smart energy system. This is a picture, if you can see it. This is where there are both gas grids and district heating grids and district cooling grids and electricity grids that will all work together in this sort of concept. We have made a small video about it that I'll promote here. So if you go into YouTube and tap in smart energy system, then it should pop up. It takes a quarter of an hour, and there you can see more details how we think all this network could work together. I'll just here highlight one of the there are several reasons for it, but one of the really major reasons why this is where we should search for the good solution, I'll just highlight here by this slide here. In this slide, maybe you cannot see it, but I can just tell you what it is. It's summarizing the costs of electricity storage compared to thermal storage and gas storage and liquid fuel storage. And it's summarizing approximately the prices of this. In this case here, the electricity storage is a pumped hydro storage. We cannot have that in Denmark because we have no mountains. We need a compressed air energy storage or something like that, or a battery or whatever. It doesn't really matter. Any kind of electricity storage defined as we put in some electricity and we take out some electricity, no matter if it's converted to hydrogen or whatever on the way. The cost of that is in the order of magnitude 100 times more than if we will try to invest in storage for thermal, that is for heat. So the initial investment cost of buying electricity storage capacity is order of magnitude 100 times more expensive than a heat storage. That is very, very important when we look at this. The heat storage, again, is 10 times more expensive than a gas storage, and a gas storage is 10 times more expensive than a liquid fuel storage. That is an oil tank, but maybe in the future that could be some kind of green methanol or something else in that tank. So just to give the order, that's why it's very important. So if we can somehow organize that the renewable energy systems work together between the heating and all this sort of factors, so we can store the energy at thermal heat or gas or liquid fuel, then we could do it much, much, much cheaper than if we try to store it as electricity. That's one point. Then there's also another one here that's more like a community point. And that is, if we try to do it individually, each of us in our own household, then it's much, much more expensive compared to if we group together and do it together. This is, here I compare the heat storage of my neighbor. I got one similar myself. That is a hot water storage tank of 160 liters. I guess many of you have such a tank in your household as well. I compare the cost per unit of that, doing that in one house with this solution up here, and that's the big water tank taken from a community heating, district heating system in Skagen in Denmark. And here they have equal to 4 cubic meters of water for each consumer. And then they have district heating pipes to the consumers and so on. And that part of the plant cost nothing compared to the rest of what they have, the pipes and the engines and so on in this. So it's really easy and cheap to get 4 cubic meter. To the down left corner, I've shown a picture of how it looks if you try to put 4 cubic meter into each flat and not having a district heating. Then you will not have room for yourself in the flat, more or less. Just to say how this is. But the numbers again here is that going from the small tank there and then going to the community tank where you can have 4 cubic meter, again, approximately the order of magnitude, it's 100 times cheaper. It's 100 times cheaper to do this together than it is to do each of us in our own house. Then I also added here down to the right corner, that is some new, very big seasonal thermal storage facilities that are being built in Denmark right now to store solar thermal for district heating from the summer to the winter on a seasonal basis. They are even a factor 10 cheaper. So there's a factor 1,000 between doing it on your own in the individual houses and then really group together and doing it on a seasonal basis. And that's why I think that the community level is extremely important here, because if we group up as a community and own a district heating system together, then we have much better facilities, not only of storing, but also of solar thermal and waste incineration and recycling waste heat from a lot of things when we do all this. Now, this is just to emphasize why the smart energy system approach is so important. When we look into the future, no matter if we do it in Denmark or for the whole of Europe, we use computer models where we model it on an hourly basis, because this is really important. And this is a free way, everybody can download it, been used by a lot of researchers around the world. But what I would like to stress here is, in that model that we have developed here, we do hourly simulations, not only of the electricity, but also of the heating and the cooling and the industry and the gas and the green gas and power to gas and all the things all together. So we can play around with, should we have electricity storage or should we have thermal storage and so on and so forth. And I can already say here now the result is that we should not really have any electricity storage apart from the batteries we need on the electric cars. But to buy electricity storage to integrate a lot of wind and PV is not really feasible. If we make these kind of integrated solutions, we can organize it in a way so we can buy much cheaper storage options as thermal heat and as gas and liquid fuel, as I mentioned. We have done some scenarios on this in the Danish context. We already, some of them we have done and together with the Danish Association of Engineers that started in 2006, because in 2006 we had a government that didn't really care about the whole energy after a long time, and then the industry and the engineers wanted to have this on the agenda again to promote the industry and all the things we were doing. And this actually ended up in that the Danish, I don't know if that was exactly because of that, but it was at least the same year the Danish government in 2006 started to have the long-term target of Denmark being fossil-free, and then later on it was defined fossil-free by 2050 and without nuclear, and that is the same as 100% renewable energy society by 2050, and that is the target of the Danish, not only the government but also the parliament, and it's been supported now by at least 4 different governments and 4 different parliaments. So this is the target of the Danish government, and they're not only saying this as a long-term target, we're actually also doing something. For example, the share of wind have now been increased. The target is to increase it from 20% by 2010, used to be, and then to 50% of the electricity being produced on wind power in 2020. And we are already on 40 as we speak here, more or less. And a number of other things being debated. But here in this we look at, and what we found out is that it is doable to do 100% renewable energy in Denmark. We can find the resources in terms of wind turbines and PV and solar and whatever we need, and also biomass. But there are two really hard corners in doing this when we made the first investigations. And the one hard thing is how much biomass can we allow ourselves to use within the energy and still claim to be some kind of sustainable. That's the one really hard question. The other really hard question is what to do about the transportation. Yes, you can say electric car, and of course we should, but what about the airplanes and the ships and all these other things? So how should we do this? Those were the things we took up in a project here that I headed with almost all universities in Denmark participating in it, and we sort of looked closer into what to do about the transportation and what about the biomass. And of course the transportation, as much electric vehicles as possible, or electric trains or whatever as possible. That is the best way of doing it, the most efficient, the way that will demand for the less wind turbines by the end of the day when we make all this up together. So the more electric car, but we cannot do everything electric car. There are the planes and the ships and the long distance transport and so on. So what to do about that? And somehow we could produce some kind of green fuel, gas or liquid fuel on biomass. But on the other hand, biomass is a limited resource. And we calculated, for example, if we should do the transportation in Denmark on rapeseed oil, for example, Denmark is not big enough. I mean, if we grew rapeseed on all of Denmark, we couldn't do it. So there is really a challenge there, and we don't want to do only rapeseed because we also like something to eat and so on. And materials if we don't have fossil fuels. Taking all this together and sort of limited ourselves to the residual resources of biomass, that is the manure that we can make gas of, the straws that is left on the field, the wood chips and so on and so forth, and also some of the waste. Well, we put that together, so biomass is a limited resource. But what we found is that if we take as much of that biomass and convert as much of that into some kind of carbon that is liquid or gaseous, and if we then take some wind power and by electrolysis put it into hydrogen and don't store it as hydrogen or use it as hydrogen, but add that hydrogen to the carbon and then produce some methane or methanol, I believe we ended on as the most obvious way of doing it, then we can do it. Then we have resources enough and we'll do it within something that we can claim is a sustainable use of biomass. We call that concept electrofuels. This is where we have some kind of electricity with electrolysis and put it in to fuels. It can also be carbon. Personally, I'm not so fond of carbon capturing storage, but I'm fond of carbon capturing recycling or carbon capturing utilization, somebody call it. So if you capture some carbon from whenever you burn something on the power station or whatever, and recycle it together with hydrogen, and then have some, then that could also be an option. We have spent a lot of time looking into how can we do this the best way, and in the book there are all these diagrams. I cannot go into details, but the basic thing about all the diagrams that I show here is that we take some carbon from some biomass and we take some hydrogen from some electrolysis and wind, and then we convert it in some green liquid fuel, methanol or methane, a green gas. That's the principle of it. And if we do that, then we think we can make the numbers match. Now I'll go back to when we take those studies and then take them to the European level, as we did here in the paper I mentioned. Then the first thing we tried to discuss was the biomass. How much biomass can we allow ourselves to use? And here it's compared to how much fossil fuels we use. And we looked at a number of studies, but we also had already made some study, because if you take Denmark, we are sort of representative, both in terms of natural gas resources and also in biomass. If we can do it in Denmark on our biomass, then on average the world should be able to do it. Of course, there will be a lot of things around it. So we limit ourselves to relatively low amount of biomass, and this should be biomass that are only residual resources and are not hindering us from food and from some kind of material. We should use some kind of biomass for material also in the future. Then based on this limitation, then we develop some kind of roadmap, and this roadmap is not going from 2017 to 2015. It's not that kind of roadmap. We are all in 2050 in this roadmap. It's more like to explain the changes that we believe and the way we prioritize those changes in order to come to an energy efficient and sufficient 100% renewable energy. So it's more like step by step. And we take out we start our journey in a prognosis from the Commission, the EU 28 countries, on a current policy initiative scenario they made a couple of years ago in the energy road map for 2050. So they are already taking us to 2050 with what kind of demands would we have there, and how would that energy look if it was a current policy initiative some years ago. So it should be incorporated, all the increases in houses and populations and that sort of things when we start out. And we don't discuss that. We discuss that in other reports, but not in this one. This is where we start out. And then the first thing we then do to change, this system is of course based very much on fossil fuels and to some extent also nuclear. So what we what we do first is something that we think there are general consensus on doing. Of course, that will be a matter of discussion if you all agree on that consensus, but that's how we look at it. Step one is to take away nuclear. We don't want nuclear in the future, so we take it completely away. If there is a consensus on that or not, we can debate here, but that's how we see it. So we take away nuclear as step one or step two here. Step three then is to do something with heat savings. We should insulate our houses better, build better buildings for the future, and even build better buildings and also insulate our houses better than just current policy initiatives would lead to. And we have made quite some investigations in different European countries on how much should you save and how much should you produce. And the basic idea of what we promote here is that we should not convert all existing buildings to zero energy houses in 2050. We don't think that's doable. We don't think it's wise to do it. It will be extremely costly if it can be done at all. What we sort of promote is that we should save until the point in which we think that producing or district heating and things like that would be cheaper, because we can recycle a lot of waste heat on that. Our calculations leads to that this is in the order of magnitude of cutting the space heating by half, not the hot water, because that will likely increase, but the space heating by half compared to now. But since it's already cut a little bit in the prognosis of current policy initiative, it will be cutting 30% compared to that on the heat savings. Also, the cost for this, in our view, is reasonable. And if we try to go further, the cost will start being quite substantial. So that's the heat savings we include here. Then we think step four is that everybody agree we should have electric vehicles, because anything else than that will really cause a lot of energy consumptions to the cars. So we also include electric vehicle here. For as many as you can imagine, that it's not, there will be some long distance, there will be some trucks, there will be some airplanes, but this is the electric vehicle. I got 5 minutes back, but I'll manage. So that also part of it. Then we look more into the heating, because also that's what we really looked a lot into in some reports we made, Heat Roadmap, Europe Studies for Euro Heat and Power. that we also promoted to the Commission. And because very often you forget the heating. And we can do it on an individual, but right now it's mostly gas boilers and oil boilers around Europe. How should we replace them? If it should be renewable energy, we could of course replace them with biomass boilers, but then there will definitely not be biomass enough for that. That will be terrible to try to do that. We can produce hydrogen, but that will take a lot of wind turbines and so on and so forth. If we want to do it in individual heating, then heat pumps is by far the most efficient way of doing it. But there are ways that are even more efficient. That is to introduce or expand. We already have 5,000 district heating companies in Europe, but expand that from around the 12% we have now to around 50%, so that we will have district heating in most urban areas. Then we can recycle the waste heat and so on and so forth. So this is what we have as step 5 and 6. And then for the transport, we suggest electric fuels, as I just explained here. And then by the end of this step, we will then replace all coal and oil with natural gas. And then in step 8, after replacing coal and oil with natural gas, we'll end up having exactly the same natural gas consumption as we had in the beginning. So we haven't expanded the fossil fuels, but we get rid of coal, oil, and nuclear. And then we could also replace, and that is a step 9 that is more debatable, but we could replace then the natural gas by doing the carbon capture and recycle and hydrogen and more wind turbines, as I mentioned before. Just for the heating, I'll just mention here, I'll start by showing this one, Heat Roadmap Europe, or some studies we did for the whole of Europe. Some of the things we showed here is that right now, if we take the electricity production in Europe on thermal units, the waste heat from that is more or less equal to the total heating of all houses in all of Europe. It's more or less the same number. So if we could somehow take some pipes from the local power station to the houses all over Europe, then we could stop importing a lot of gas and oil. That's not what we do. Instead of going that 1 kilometer or a few kilometers, what we do in Europe mostly is that we drill in Siberia and take the gas around the world and into each house, while the waste heat is wasted. And we really got, and it's not only, as I should show here, because in the future there will be less thermal power, of course, because we have more wind power and PV and so on. But then there will be a lot of other waste heats that we can benefit from here. There will still be the industry. There will be all the energy conversion as we foresee it, from taking biomass into liquid liquid and gaseous fuels. There will be all the electrolysis and so on. So there will be a lot of waste heat also in the future. And of course, we should also save energy for the houses. My 5 minutes are more or less spent here, so I'll rush through. This is more showing the numbers of all these steps here. This is the primary energy supply. You can say it's step by step, and then coming from the fossil fuels and gas, coal, and oil, and nuclear, and then ending up in biomass and wind or renewable energy. You can also show it from the renewable share part of it, going from a small share up to 100%, and also for the carbon dioxide emissions, more or less being carbon dioxide emissions free by the end of it. We have also calculated the costs, and the cost is that, as far as we can see, it will not cost more than we pay now, maybe a little more, but not really. And the big cost, if you look at this, is not so much the power stations and the wind and the district heating and so on. The big cost are really the cars. I mean, what we have invested in cars is very, very big number as compared to what we have invested. And this is just the additional cost of having electric cars instead of petrol cars and so on and so forth. So, but one major important thing about this kind of investment, and this is also very important for the local communities, of course, is that if we end up in the fossil fuel, then we spend all our money on importing oil and gas, and maybe also coal in the future. While if we end up in this, then we spend all our money in construction works, like district heating pipe and insulation material and wind turbines and so on and all the sort of things. And if we can do that construction in Europe ourselves, and I believe certainly we can, maybe we're the best to do it as it is, then this will mean jobs. For the Heat Roadmap Europe study, we calculated that doing district heating instead of importing gas will mean 200,000 jobs in Europe on a permanent, because while we're doing all this, at least until 2050. So there's really a lot of jobs here, and really a boost of the economy. And the wonderful thing about this is that we can actually create jobs without getting it for free, because it's not so that the energy will cost a lot more. It's more or less the same cost, but instead of paying it out of Europe, we'll pay it in Europe to do all the construction work. And that is, of course, a major difference. So this is really where we have an option in Europe to do something that will not cost us a lot, but will really generate jobs and will really mean a growth to the GDP and so on. Thank you very much for your patience. There's a lot of links here, both to the video and the reports and the books and anything like that. Thank you very much.
So once again, let's take a few minutes for some questions. 2 questions.
Can you tell us something about changing to electrical cars in Denmark? You know, we have a very big discussion in Germany about Dieselgate and Volkswagen. We have a shock for our premium cars because of Tesla. And Denmark is not producing own cars. How is it running? You have which type of cars you're selling, you know, like the Norwegian or the Dutch. They say we won't have any more cars up to 2030, which is run by fuel fossils. How is it going in Denmark?
This is where, on this particular point, this is where Denmark is certainly not Valhalla. It's not going very well. We were actually on the right track a couple of years ago, but and we are sort of perfect to doing it. That's also why some of the manufacturers look for Denmark, because we have all the wind turbines at the same time as we have a lot of crazy taxes in Denmark. So we really tax the cars. We tax the cars by 150% plus the VAT and so on. And we actually had a scheme where we didn't tax the electric car. And for that reason, they were expanding. But the present government actually put now a tax on it. So it stopped the expansion of electric cars in Denmark. And that is, of course, being heavily debated, how to put that on the right track again. So don't look for Denmark, look for Norway, maybe even better in Germany. Don't look for Denmark on that particular point. But I hope we'll certainly be on track. As far as I see, this is the only way forward, that is to look much more into the electric vehicle, for sure.
Merci pour toutes ces informations intéressantes. Je voudrais réagir à la fois par rapport à cette conférence et la conférence précédente. Donc il y a beaucoup de choses que j'ai entendues avec lesquelles je peux être d'accord, mais en même temps je fais aussi partie de ceux qui pensent qu'on pourrait qualifier les énergies renouvelables d'illusions renouvelables, dans la mesure où la réflexion est essentiellement technicienne et économique, et qu'il n'y a quasiment pas de réflexion philosophique. Par exemple, dans notre société d'aujourd'hui, nous consommons plus de 15 litres de pétrole équivalent par personne et par jour. Quel serait le niveau de consommation d'énergie raisonnable, durable et extensible à 7 milliards ou plus d'habitants sur la Terre? Juste une petite... je n'ai pas le temps de développer, mais juste une petite... un petit constat technique. En ce qui concerne le renouvelable, on sait qu'il faut à peu près 10 fois plus de métaux, investir 10 fois plus de métaux pour produire une quantité d'énergie équivalente à celle qu'on obtient par le pétrole. Voilà.
I didn't hear all of it, but I believe this is more like a comment than a question, isn't it? Or you think it's...
Sauf sur la question peut-être de la réflexion philosophique.
Well, yes, of course I can do that. Even though I wouldn't really call it a philosophical as you do, but if it's the question that I very often get, that renewable energy is not realistic. I heard that many times because I've been in this business for many time. My answer to that is renewable energy is the only realistic solution we have. That is the only everlasting solution that we have. Fossil fuels is not realistic for obvious reasons. I remember once that was in Galway. I made a speech to some students there, and we discussed some things. And then when I answered, I said, "Yes, but you must remember, I'm going for the 100% renewable energy. That's what I'm discussing." And then one student said, "Yes, but that's the dream." And I replied, "Yes, but the alternative is a nightmare." So of course you can find all kind of obstacles, like all kind of problems for renewable energy, and there are a lot of challenges and problems. But I think this is the only realistic way.
Yes, I see so many hands going up now, and we are just a few minutes late. So I would like to ask everyone, as sorry as I am about this, to put your questions into the coffee break, or maybe you can sit next to Professor Lund at lunch. At least 2 people can do that. So thank you very much.
Thank you very much, all of you. Thanks.